welcome back. We're going to talk about section 3.1 today. And 3.1 is about what are called contingency tables. And contingency tables are a way of displaying or investigating the association between two categorical variables. So if you have two different variables that are putting people or objects into different categories or slots, then a contingency table can help you see whether one of those variables seems to be influencing the other or explaining changes you see in the other. So the variable that does the explaining is called the explanatory variable, and the variable that depends on or is explained by the explanatory variable is called the response variable. So we're going to go through the series of examples that are in the guided notes about blood type. So hopefully you've had a chance to take a crack at those yourselves. But we'll kind of check to see how that went and use a little bit of the vocabulary from the section along the way. So the first thing is we have our contingency table where we have the blood group down the first column and whether the blood group is positive or negative is along the first row. And then along every row we have the totals for each row. So the number of folks that have blood group O would be the 14 that are negative plus the 76 that are positive. That's my total of 90 for those that are type O. Type A is 12 plus 68 or 80. Type B is 4 plus 18 or 22. And type AB is 2 plus 6, which equals 8. So we have 90 O's, 80 A's, 22 B's, and 8 AB's. If you total those all up, you get 200. So 90 plus 80 is 170, 192 plus 8, 200. Now the table also gives totals down the columns. So for all of the folks that have blood types that are negative, we have 14 plus 12 is 26, plus 4 is 30, plus 2 is 32. There's my negative total. And then the positive total, 76 plus 68 plus 18 plus 6 is 168. So that's where the totals come from, and we'll refer to these through a lot of the exercises. So let's see. The first question is to find the percent or proportion of folks that are positive, right, of all blood types that are positive. So we would take a look at the total number of folks that are positive, 168. The proportion of those would be 168 divided by 200. So this would be 168 over 200. So I'll get my calculator to do that. So that's a 0.84 or an 84%. The second part of this one is to figure out the percentage or proportion of folks that have blood type B. So here we look along the column for B. We know we have 22 total that have that type. Divided by the total number of folks, we get 22 over 200. Which is about 11%. All right, so the next example involves using the word or, and there is one thing you have to be a little bit careful about when you're dealing with or percentages. So this first one is the percent of folks that are O or B. So we have 90 that are O, 22 that are B. So that's 90 plus 22 out of the total of 200. And let's see what that comes out to be. So that's about 56%. So out of all the people that we have blood types for, there are 90 that are either O or B. 90 plus 22 that are either O or B. Now, what about B or positive? Well, this is where we have to be a little careful because here are all the people that are positive. There are 168 of them. And here are all the people that have blood type B. There are 22 of them. But we can't count that 18 twice. So we have the 168 that are positive plus 22 that are type B, but we have to subtract out the 18 that we counted twice. We counted them as part of B and counted them as part of the positive. So this would be 168 positive people plus 22 B types minus the 18 that we counted twice. So that in total 86%, 0.86. 4, 11, 56, 86. So that's what I meant when I said you have to be a little careful with OR, because you're summing all the things that fit that description, but occasionally you'll add something twice, and you need to make sure that those folks don't double count. All right, so next up, we have some what are called joint probabilities, where you're figuring out or percentages where you have an and description. So number 4, part A, is the percent of folks that are both B and positive. All right, so here's B, here's positive. B and positive would be the 18 out of 200. 0.09. And then asking the number or percent of folks that are AB negative is the same as saying AB and negative. Okay, so we've got AB and negative. There are only 2 of those folks. So 2 out of 200, so 0.01. So those are joint percentages or joint probabilities. Next up, we have what are called conditional probabilities, where we first, before figuring out a percent, we restrict our attention to some subset of the population. And what that usually means is restricting our attention to either a row or a column in the contingency table. So exercise, or example 5, part A, is asking us what percent of the people have type AB among the positive people. So given that we know someone is positive, what's the percent that that person is also AB? So here's my conditional probability. I'm conditioning on it being positive. So this is the column I'm interested in. So out of those folks, the ones that are AB are here. That's my 6. There are a total of 168 positive, so 6 out of 168 is that one. Let's see, I'll go ahead and just round to the second place, so that will be a 0.04. So the next one asks, given that we know a blood type to be AB, what's the percent of those that are negative? So if we're restricting ourselves to blood type AB, we're in this row. All right, we have 8 folks that are AB negative, that are AB. The ones that are negative among the ABs are just the 2 in this cell. So 2 out of the 8 that have AB is the percent that are negative given AB. That's 0.25. Now, Example 6 asks us to continue this process where we are going to fill in a table of conditional probabilities or conditional proportions by blood type. So notice that the first one appears already filled in your guided notes, where given blood type AB, 25% of those were positive, were negative, and 75% were positive. Right, so that was the 2 out of 8 and the 6 out of 8. Right, now I'll go through type A. So given blood type A, what percent or proportion are negative and which are positive? Well, the negative ones for A are 12 out of the total of 80 who have blood type A. So given A, negative proportion would be 12 divided by 80. That's a 0.15. And, well, you can do it one of two ways. You can take, to find the percent that are positive, you can take 68 divided by 80 to get 0.85. Or you can notice that we only have 2 spots and they have to add to 1. So if you know that the percent or proportion negative is 0.15, then positive has to be 0.85. Okay. All right, so if we look at proportion negative by blood type, we see that there's a fair amount of variation. 25% of AB folks down to 15% of type A. So let's take a look at the questions for 6. Is there an association between the two variables? We would say yes. Because the blood type seems to influence the differences we see in negative and positive. So AB, we have 25% negative, but type A, we only have 15% negative. So the blood type seems to explain at least some of the variation that we see in split between positive and negative. All right. What about question B? Which blood type is most likely to have the Rh antigen? In other words, which blood type is most likely to be positive? And it looks like the largest proportion of positive is for blood type A. All right, so the final question on this section, is a person with blood type O or blood type B more likely to be negative? O is 16% negative, B is 18% negative, so that's going to be blood type B. And the proportion of people with O who are negative compared to those with B who are negative is 0.18 minus 0.16, 0.02, or 2 percentage points higher than the people who have B. Sorry, hopefully I said 16. I wrote 12. So we're taking a proportion of B that are negative minus a proportion of O that are negative. That's a difference of 0.02 or 2%. Got to be careful though, we don't say 2% here, we say 2 percentage points. Because saying that something is 2% higher has a different meaning. So when we're comparing proportions, we're going to be careful to say percentage points higher or lower. All right, B is the proportion of people with blood type B who are negative is how many times the proportion of those blood type O that are negative. So we have B negative divided by proportion of O that are negative. And let me that 18 divided by 16 is a 1.5. So that's our ratio of the proportions. And right here, this says that we're about we're 12.5% higher for the 0.18 than we are the 0.16. So this would be filling in blank 12.5% higher. Right? And that, again, is because the ratio of the proportions turned out to be 1.125. That 0.125 indicates 12.5%. That's how much higher as a multiple 18 is compared to 16. And finally, are the two variables independent? No. If the variables were independent, then we would expect to have the same proportions in both O and B. But we have a difference in proportions, so these seem to be associated, although not a terribly large association, and we would have to be a little careful, as we will be later in the course, to kind of figure out whether that difference is enough to be considered significant, or if we think that might just be some random fluctuation. All right, so that's going to do it for this video. The next one will be talking about scatter plots.